Okay, here there are a couple of three questions. We can see what we can do with them. A bit of practice questions. All right, let me just complete this. That's the ranges. Right, okay. Two trick questions. They want us to solve them. Solve. Okay. Solve these two questions. So let's see how far we can go with this. All right, so the question one, basically the question one they're talking about. Let's take the first question. Let me rewrite it. 2 sine theta minus 1 times 2 cos theta minus root 3 equals 0. So if you look at this carefully, it looks like obviously it's not looks like, it is. These are two factors basically, isn't it? It's been factorized. There are two factors, that times that, basically they say equal to 0. Which means, the meaning of this, what is the meaning of this? Which means this could be equal to 0, or this could be equal to 0. Okay, it's like having two factors. X minus 1 bracket x plus 2 equals 0, which means each bracket could be equal to 0. So this solving this seems to be pretty simple now. So we can say then 2 sine theta minus 1 equals 0. So one of the outcomes, possibilities. So you can say other one, 2 cos theta minus root 3 equals 0. This yields sine theta equals a half. This yields cos theta root 3 over 2. Now, as we know, the ranges are given. Theta should be in the range of minus 180 to 360. Okay, so we can solve them, both of them actually, by sketching curves, sketching cos and sine graphs. So it's like we are having two separate questions now to find theta, because we are asking for theta. Solve for theta basically. Solve for theta. We are looking at the value of theta. So what you would do? Let's take this first. Sine theta equals half. So I'm going to draw a sine graph. This sine theta. That's theta. So let's go with this. That's the sine graph. As we know, sine varies basically between plus 1 and minus 1. Okay. Oops. Minus 1. Sorry, plus 1 and minus 1. And this is sine theta equals half. So what we're going to do, we can draw the sine theta equals half basically. So that's sine theta line. That's a y-axis. Sine theta is half. So we can just draw it like that, a line. However, this is restricted from there to there. So the restrictions are applied. So so we don't really have to bother below minus 180, isn't it? So there are restrictions. So I'm going to just delete this part of the graph because it's not required. And also I'm going to delete, that's what I'm going to delete here because that's it. So that is 180, that's 360 here. That's minus 180, okay? So there seems to be two solutions here. Right, two solutions. What the solutions are, that's the one solution, that's the one solution. So the solution, we are looking at the theta values which yields those solutions. Theta, that is one of them. That's one of theta, that's one of thetas. So the rest, what we're going to do now to find these values, we can use a calculator. Theta equals sine inverse half. So you're going to get the first value. You can use the calculator, I can run a few values. The first, this would be basically 30 degrees. 30 degrees. So this would be 30 degrees. And we can look in the pattern of the symmetry, and you know that's 180, and this should be 150 degrees. There you go. So we got these values for these ones. The values are here. Then 150 degrees, theta could be 150 or 30. Okay. There's one of them. And there's another one, however, don't forget this. Cos theta equals root 3 over 2 as well. So then we can do that separately. Okay. So let me do that. Let me do it somewhere here. cos theta graph. That's also for the same range, so we can we draw basically that's it. Okay, so they wants to draw it from minus 180 to plus 360. Yeah, so that's 360. And I would like to remind you, please practice sketching these sort of graphs. Very useful knowing how to sketch. Useful sketches are useful. Okay then, so that's good enough. It doesn't have to be perfect or something, just useful sketches are what we are looking at. Alright, anyways, so that's root 3 over 2. So again, this also varies between that plus 1 and minus 1, obviously, we know that. And this is cos theta, cos graph, by the way, cos theta, and that's theta. So I'm just going to draw a line. There you go. It doesn't have to, you can draw it either, it doesn't really matter where you're drawing it. It's a matter of symmetry, as long as you can recognize that. It doesn't really matter, because we can't just calibrate and just draw it. There's no point. You know, you don't really have to do that. You just have to be just sensible, basically. Sensibility is what matters. Right, so if you do that using a calculator, theta equals a cos inverse root 3 over 2, we're going to get basically, I can remember certain values again, you can use a calculator anytime, you're going to get basically 60 degrees, 30 degrees. Okay, so cos root 3 over 2. Okay, so yeah. Now we got the first angle is 30 degrees, and the second angle would be here. There are again two solutions. Sorry, actually three solutions are here. By symmetry, we can straight away see that is minus 30. Okay. And this one here, from there that is 30 degrees, that is 30 degrees from there, then from there to there is 30 degrees. See, we have to look into the symmetry again. It's symmetrical. Like the same like wedges, isn't it? Can you see that if you cut a piece, basically that which is 30 degrees. So we're going to get 330 minus 30, which is basically 330. Okay, 360 minus 30. Go back. So we got three answers here. The answers are theta equals to minus 30, plus 30, and 330. Okay, so that's basically it. So that's the first question. Alright. It's all about actually just looking at it and using a bit of algebra. Alright, so let me try the second question then. So I'm going to get rid of this. Okay. Second question, if you look in the second question, it's looks like a quadratic one, isn't it? It looks like a quadratic nature. It has a nature of quadratic functions. It has a nature of quadratic functions. Oh. Yeah. So it has a nature of quadratic functions. So let's see what we can do with this. Now, let's say this says 2 sine square theta minus 3 sine theta plus 1 equals 0. Now, let's say this question was look like, let's say it's look like 2x squared minus 3x plus 1 equals 0. Let's say we try to solve this. What you would do here, you would basically factorize it, wouldn't we? Factorize it. So we can do the same thing. So let's say x equals to sine theta. So as a replacement, x equals sine theta. So we can possibly factorize it if we can. 2 times 1 is 2. So we try to find two numbers, times them together to give us 2. Add them together give us minus 3. So it seems to be minus 1 and minus 2. Ideal. Times them together give us 2 and add them together give us minus 3. By the way, this 2 come from 2 times 1 is 2. So I can rewrite this one as 2x minus 1 minus x minus 2x plus 1 equals 0. The factorization here involving common factor here is x, so I'm going to get 2x minus 1. Common factor here is minus 1, I'm going to get 2x again minus 1 equals 0. You're going to get 2x minus 1 equals 0. And sorry, just being too hurried. This factorizing first. Factorization hasn't finished. 2x minus 1 and x minus 1 equals 0. This is factorizing. Okay. This yields us 2x minus 1 equals 0. Oh, x minus 1 equals 0. And x equals to half. And x equals to 1. Okay. Right. So we were not looking at x, actually we were looking at really looking at theta, isn't it? We are trying to solve this for theta. And also we changed the question, if not we substituted x equals sine theta. So what we're gonna do now, we're gonna put it back into x, because x equals actually sine theta. I'm gonna go back to the original equation. Sine theta then must be equals to half now. The reason is because x equals sine theta. So, and we have another portion of it also saying sine theta must be equals to 1, because why? X equals sine theta. Now we can solve it again. They want us to range of this. The same thing like what we did before. We can sketch a nice graph. Beautiful graph from minus 360 plus 360. So we can go minus 3, there you go, minus 180, what I meant, and plus 360. Okay, a sine theta graph. Alright, so that's half. I mean, let me draw it a bit bigger probably. A slightly bigger version of it. You guys can see better. So there you go. So that's basically plus 1, the maximum value of sine, minimum value of sine, negative 1, and that is the sine theta. Alright, so right, so these don't get confused with these lines, they're just no lines, the minus 1 plus 1. So sine theta basically is half, so I can just draw the line of half here. There you go, that's half. There are two places intersecting, but we are looking at the values that intersection occurs. Again, we can do sine inverse half. We're going to get basically theta would be again 30 degrees, because sine inverse half would be 30. So that's the first answer is 30. The second answer would be that's 180. So 30 come from there, so 150 degrees of symmetry. So we got one answer is 30, another answer is 150 degrees. The other one, again, we can do the same thing. Maybe a little graph. Okay, so that is sine theta. That's theta. Sine theta equals 1. Wow, that's an interesting case. So it's going just from on the tip of it. There you go. Tip, because why? That's also 1. So we got only one answer, 9 degrees. So here we got theta equals 90. So we got all the answers, 90, 30 and 150. So we can rewrite all the answers here. The second question, all the answers are, we can accumulate all the answers and just put 90, 30, summarize the answers, what I meant, 150, that's it. Okay, mate? I hope this is some sort of help. two types of questions. So keep in your mind, if you get a quadratic or whatever thing, you can just factorize highly likely, or they might give you something already factorized. So these are very popular questions, for a lot of marks, and relatively easy, I would say, once you know it. Alright, cool. I think that's good enough. Cool.